Okay, here's a quiz we just took very recently here, and let's just go through them all. Let's try to do it all in one shot right here. Find the area of the parallelogram. Look, there's just some basic formulas you have to remember, and the area of a parallelogram is just the base times the height. Some of you guys are putting a half in there. It's not. It's just the base times the height. So here is the parallelogram. Where is the base? The base is this whole entire thing right here. It's not just the 8, it's not just the 10. It's the 18. That's your base. And what is the height? It's that perpendicular distance right there. That right there is the height of your parallelogram. So all you do is just multiply those two numbers together. So the area is 18 times 16. When you multiply those together, you get 288. It's in inches. Inches squared. I didn't count off if you didn't put that on there. That's all there is to it. Very simple. Some of you guys are putting angles in here, trying to do trig, trying to do all this crazy stuff. All you got to do is the base and the height. That's the whole base. That's the height. And that's it. Look at this. This is almost just as easy. So you got to know the area of a triangle, though. You'd have to memorize these formulas. Some of you guys, I can tell, are just not memorizing the formulas. It just takes time and a little bit of effort to go through and memorize some of these formulas. These are formulas you've learned since grade school, especially like this. Length times width, base times height, it's the same thing. You remember that. And same thing with this. It's 1/2 the base times the height. That's the area of a triangle. So let's put some numbers in. It's 1/2 times the base. Look at this triangle. This is the triangle right here. Even in class, I said it's the solid line. Some people were thinking it was this triangle. I even said in class, it's this triangle right here. The solid lines don't represent part of the actual triangle. Okay, they're just extensions and imaginary lines, I guess. So what's the base of this triangle? Well, it's 25. So it's 1/2 times 25 times the height. What's the height? The reason they put this dot in here, this dotted line, is because that is the height. It's from the top. If it's an obtuse triangle, it's going to be outside the triangle. So that's the height. It's perpendicular to this base. If I was to take the base and extend it out, it would hit right here. So that's 17. All right. So you just plug that in your calculator and you get 212.5. I'm just going to put the numbers there. I'm not going to put the units. All right, if that's okay with you. I hope that doesn't bother you. Some teachers would probably flip out by not putting the units. And if it was a higher level class, if it was like I used to teach physics, and in physics I would take points off for that kind of stuff because that's very important. Units are very, very important when it comes to that kind of thing. But right now I just want you to learn how to find the area. Look at this one. This is easy. It's only easy if you know the formula. There's a formula for the area of the kite and the area of the rhombus. It's the same exact formula. It's 1/2 D1 times D2. It's not plus. Can't tell you how many times I saw plus on the quizzes when I was grading them, and a lot of people didn't put the 1/2 there. It's a matter of just you sitting down and memorizing the formulas. I said when you were doing these worksheets, I said every time you do one of these, you should write the formula down right next to it. Don't just write it once and refer to one formula. Write it down every single time. And I don't think some of you guys are doing that. That's why you don't have the formulas memorized. Okay, enough yelling at you. Let's do the problem. So area is 1/2. Look, they tell you both of the diagonals. They tell you that. It's kind of hard to see right here. That's a 13. That's the same distance as from here to here. That's the diagonal. Okay, watch this. Let me put that line in there. Okay, that right there is the diagonal, but it's the same length as this. That's 13. And there's another diagonal from this corner to this corner, or vertex to vertex. There it is, about right there. Okay, that line right there is the same as that 8. Those are your two diagonals. It's exactly how they wrote them in the worksheets and when we did that in homework. Okay, so here we go. D1, D2, the two diagonals, that's 13 and that's 8. Throw that in your calculator and you get 52. So the area is 52. That's all there is to that. This is almost the same exact type of problem. One little twist to it. Okay, remember I said from here to here is 8, and then from here to here is going to be 8 too, because it says there's a rhombus. The diagonals bisect each other on a rhombus. So if whatever this length is, that's going to be the same thing. Whatever this length is, that's going to be the same thing right there. So what are my diagonals? My diagonals are not 8. Again, a lot of people did that. They got the right formula, then they put 8 in for the diagonal. It's not 8. What's the diagonal? It's from here all the way to here, and that's 16. Even in class, I stood up in front of you and said, this is only half of the whole diagonal. So 16 is a diagonal, 10 is a diagonal. So my formula for area of a rhombus is, remember, it's the same as the area of a kite. It's 1/2 times one diameter, call it 16, times another diameter, which is 10. All right? Throw that into a calculator, and you get 80. And then it's centimeters squared, but I'm fine with just writing 80, okay, with that, for now anyway. Later on, when you get into other classes, they're going to be real picky about that kind of stuff. In here, it doesn't bother me so much. All right, let's keep moving. If I'm going too fast, stop the video, pause it, go back, listen to what I said again, take some notes, try the problem yourself, okay? Pause it and go back and listen to it several times. What's the area of a trapezoid? Now look, you don't have to absolutely draw a trapezoid for this. You should just have the formula memorized, but I will. Some of you guys had no idea even what a trapezoid was. Well, that's what you got to study. That's what you have to stay up on. So this would be an example of a trapezoid. Two parallel sides. The other two sides are not parallel. What's the area of the trapezoid? It has bases 15 and 7.5. So let's say that is one base, that's 7.5. Let's say this base is 15. And the height is 11. How do you do the height? The height is from the top, perpendicular to the bottom. So that dotted line right there would be the height. That would be 11. All right, that's well and good that you know what it looks like, but you got to know how to do the formula. Remember, we talked about the area of a trapezoid is really close to the area of a triangle. Remember, the area of the triangle is 1/2 the base times the height. But what's true about a trapezoid? It doesn't just have one base. It even says it right there, bases. So what do you do with those two bases? You add them up. 15 plus 7.5. So that's 1/2, and that's the base, or the bases, times the height, and the height is 11. That's why you didn't really have to draw it out to be able to do this, because look, I told you everything. I told you the bases, and I told you the height. And if you know the formula, that's the key, excuse me, you can just plug it in and see what you get. And you should get 123.75, 123.75, or you could have said 0.8, because I think I did say to round it to the nearest tenth. Again, I'm not being picky on that either. Really, all I'm trying to get you to do is to understand these formulas and putting the right numbers in the formulas. I'm not taking points off for the units. I'm not taking points off if you don't round to how I told you to round, okay? I just want to make sure that you know you're putting the right numbers into the right formula, and that's what I'm looking for. Let's do this one. Most people got this right, but I did have people miss this. Find the area of a circle. Again, how many times have I said this? We have to memorize the formulas. This is all about knowing the formulas. So, area of a circle is pi r squared. Again, this is a formula that you learned back when you were a kid. You may not have learned the area of a trapezoid. I know you learned pi r squared when you were in elementary school or early middle school. You probably learned that. So let's do that. That's pi times the radius squared. Look what they tell you. They tell you the radius is 7. So you put a 7 in here. I had somebody put 7 squared as 48. Come on, 7 squared, it's 49 pi. If you want to leave it like that, feel free to do so. You can leave it like that. But most of you put it into a calculator, and that's fine also. So most accepted answer was that right there, 153.9. If you wanted to keep it 49 pi, that's fine, but that bugs people. They don't like the pi there. It kind of bothers them. So there we go. All right. Tell you what, I'm going to come back to number 7. We'll do that last. That was definitely the most difficult out of all the problems. I had to give you at least one that was kind of tough. Everything else has just been plug and chug. Know the formula, stick the numbers in, bang, you get an answer. All right? This one you actually had to do a few extra steps. This one right here, this one took a little bit of extra time. I'm getting tired of that color. Let's go to this green, this ugly green color. Alright, so what I'm going to do here is I'm going to find the area of this figure. I probably should have said that this was a right angle right there. I probably was a little remiss in not telling you that. But I think you all assumed it. I don't think anybody got this wrong because they didn't realize that was a right angle. So what do we have to do? We're going to find the area of the two things, add them together. So let's just take a look at this. What is that? That's a rectangle. One side is 10, the other side is 15. So the area of a rectangle is just the base times the height. So it's 15 times 10. Look, I can do that without a calculator. So that's 150. It's not my final answer though. I remember some people putting 150 for their answer. That's just this part right here. Well, we also have to find, just make this darker green. Okay, you also have to find this thing right here, which is a triangle. Probably shouldn't have done all that stuff, just because I'm going to put another thing in here. Watch this. How do you find the area of a triangle? The area of a triangle is 1/2 the base times the height. Well, if you look at this triangle right here, this is your height. Now, why did I consider that right there to be my height? And it's a little tough to see. Let's make it a little bit thicker. Okay. Hope I don't know if I picked the right color or not. Let's make it a darker color. Let's make it blue. There we go. That's the height right there. That's what we have to find. Sorry, can't write and think at the same time. That's our height. So this would be our base, and what is it from here to here? It's the same thing as this. It's 10. So the area of the triangle is 1/2 the base. This right here is the base. It's 10 times the height. That little blue line right there is the height. How do I find the height? Well, look at this number down here, this 20. From here all the way to here is 20. This right here is 15. So what is it from here to here? Well, 20 minus 15, that's 5. That's the same length of that blue one right there, is just 5. All right. So you can do this. Half of 10 is 5. That's 25. So what's 150 plus 25? That's 175, and that's the area of this thing right here. So where am I going to put that? I'm running out of room. It's 175. That is the area of this whole thing. So this one right here is 150. This one right here is 25. You add them together, it's 175. All right. Don't let me forget to go to number 7, okay? I know you can't talk to me. I get it. All right. Here we go. Let's try. What color haven't we used? Let's use this nice purple. And we can write right on here, couldn't we? So let's see what we're going to do. We're going to find the area of the shaded region right here. Now you don't know this area, and that's what you're trying to find. Let's just make it A. Remember in class, I think we made it A2, made this A1 and A2. We'll just call it A for area. And you have to memorize the formula. Wow, I'm getting tired of hearing that, aren't you? But you do. You got to memorize. There's a little formula that they give you to do this. Now, I'm trying to solve for A, and some of you guys are not taking my advice on this, and I really would plead with you to take my advice on this because I think it makes it a lot easier. If I'm trying to solve for A, I'm going to put A on top, right? Don't just go the order that it looks in the picture. If I'm going to solve for A, I want to put A on the top. So if I'm solving for that, I put that on the top. Now, I got to make some comparisons. This is a proportion, all right? They're two fractions set equal to each other. That's a proportion. So I take A over what? The other area. What's the other area? It's 20. So I put this area over the other area. So big area over little area equals what? Then I got to go big side over little side. But I don't just do side to side. What's the formula tell me? What did we talk about? I've got to go big side and square it. That's the formula. You say, why do you square it? Well, just because you do, and that's the formula, and I told you. I actually went through, I think in one of the classes, I think 4th period, I went through and kind of gave a little sketchy explanation of why that's true, but for the sake of just getting it right on the test, let's just make sure that we know to square it. So I'm comparing, watch, if I went the big area to the little area, I'm going to go the big side to the little side, but I have to do the square of the side. So 44 squared over 11 squared. That's all you got to be able to do. I had some people comparing this to this, and then going the other way, this to this. Look, do it the way that I told you to do it. I think it'll make it a lot easier for you. Compare the areas to each other, and then compare the square of the sides to each other. When I say that, it means I square the sides. Look, now watch why I said to get that A on top. Put that A on the top, because I got to do one step and I'm basically done, except for the calculator. I just multiply by 20. It's on the bottom, so I multiply it. And look, I don't have to do cross multiplication. I don't have to try to get A up in the numerator. It's already in the numerator. It's already on top. It just makes it so much easier that way. So now, when I throw that into my calculator, and I'll let you do that on your own, that's going to come out to 320. So A equals 320. And I was pretty pleased that most, I'd say probably more people got 9 and 10 right than got any of the other problems right. So that was a good thing, I guess. as far as that's concerned. Let's look at this right here. Now this time we have to solve for x. This one we solve for the area, this one we're solving for the side. Now remember what I said, whatever one we're solving for, that's the one that goes on the top. So if I'm solving for x, that goes on the top. But it's a length of a side. So in this formula, when you compare the areas of one polygon to the other, you square the side. So I've got to go x squared to what? Well, the other side, which is 21. And then I have to square that as well. Right? Why? Because that's the formula. That's what it tells you to do. So if I compare the right side to the left side, I got to compare the right area to the left area. Now I don't square the areas. I only square the sides. Right? You just got to keep that in mind. You only square the sides. What about this? I'm comparing 510 to 4590. All right? Now look, it's not that hard. We basically do the same thing over here with one little extra step, but watch, how do I get rid of this 21 squared? I don't need to put that in a calculator to get some big old number right here. I'm just going to say, oh, I multiplied by 21 squared. So I come over here and I multiply by 21 squared. If you don't like that dot, put it in parentheses then. All right. Now, x squared is equal to all this. Don't just put all this in your calculator and get some number. It's going to be some crazy huge number. It's going to be way bigger than 21. And you don't want that, right? What you want is you've got to get the square root. Because x squared equals this, so how do I get rid of the square root? Remember how I always do that? I just x it out. So I get rid of the square by taking the square root. So take the square root. Looks a little ugly, but just throw that in your calculator. Right? So I would go 510 times 21 squared divided by 4590 equals second function. Well, actually, you might have a square root button on your calculator. Then you hit square root, and then bang, you should get your answer. X equals 7. And that comes out nice and perfect. It doesn't even round to 7. It comes out exactly to 7, which is pretty cool. All right? And that's how you solve for x. Look, it should make sense. It should make sense because that's a lot smaller than 21. Don't get a number that's bigger than 21 and expect this to be right. Because look, if the area is smaller, the side has to be smaller. So use common sense when you do these problems. All right, I told you, remind me to go do that other one, didn't I? So now we are ready for it. I'll tell you what, I'm not even going to pause or anything. Let me find, this is a hexagon. So I believe I have hexagon over here somewhere. So let's just work with it nice and big. There we go. Copy it, and let's drop it down to right here. And let's make it real big because we're going to have to do some drawing on this picture. So that's why I want to do this separately and make it pretty big. And they tell you one thing. They go from the center of this hexagon and they go perpendicular to the side. Well, you should know what that is. When you go from the center to the side, that's the apothem, right? A. But they tell you what that number is, and they tell you it is 6. And what are they asking for? They're asking for the area of this hexagon. Well, you have a formula for the area of a regular polygon. Again, another formula. How many is that? I haven't kept count. I'd probably say 6 or 7 or 8 maybe. Formulas that you have to memorize. Most of these formulas you had memorized when you were a little kid, so it shouldn't be like you're memorizing everything from scratch. This one definitely you memorized just recently. I really, really doubt that you knew this formula before we did this chapter. But what is it? It's 1/2 the apothem times p. What does p stand for? That's the perimeter, the distance around this polygon. So look, we're halfway done already without even doing anything. We're halfway done because look, apothem. They told me the apothem. They told me that number right there, which is 6. So all I have to do is find the perimeter. You say, yeah, right. It sounds easy, but it's not as bad as you think. Look, this is what we do. Some of you guys didn't even start this thing. So you got to draw this angle right here, or this line right here, to this corner, to this vertex. Don't draw it here. Don't draw another apothem. We never did that, right? Just do what I do here. Take this and draw it to that vertex right there. Now you say, well, how does that help me? Because I'm trying to find the perimeter. So what I need to do is I need to find the length of this side right here. And then what I would do is take the length of this side, multiply it by 6, right? Because there's 6 sides, they're all exactly the same, and then that would be your perimeter. So the key is to find this side right here. Look, I'm not even finding this whole entire side first. What I'm going to do is I'm going to find this little portion right here. Why do I find that little portion? Because I've got a right triangle and I can find this little side of that right triangle. Then I can find the whole side, then I can multiply it by 6 and get the whole entire perimeter. So how do I do that? I only know one side. That's the only thing I know. Well, I do know it. There's a right angle right there, so that's kind of nice. But that really doesn't help me a whole lot right now. But we find this angle right here. That angle, that's what I'm trying to find. If you remember, what we did when I taught this thing is we drew all these triangles. Remember, we drew it to here, to here, to here, to here. And how many do we have? If there's 6 sides, there'll be 6 triangles. And they're all exactly the same. So how many degrees is all the way around the whole entire thing? It's 360. Divided by how many triangles would we have there? We'd have 6 of them. Because it's 6 sides. If it was an octagon, you go 360 divided by 8. If it was a pentagon, you go 360 divided by 5. But it's not. It's a hexagon, 6 sides. So we go 360 divided by 6. I actually gave you this one because it comes out a little bit easier. And that comes out to 60 degrees. What is that? That's this whole angle right here. Not this little one, the whole thing. So if I know the whole thing is 60, then what's this little bit right here? Well, that would be 30. Now, that really helps a lot, because look, that's 30, and that's 90, so this has to be 60 right here as well. They don't all come out nice and pretty like this, right? But this one happens to. It doesn't happen to. I put this on here for a reason, because I wanted you to know about 30, 60, 90 triangles. So let's take a look without doing any trig. Some of you guys did some trig, and you said opposite over adjacent, and that would actually be okay. You could do that. All right, but I'm telling you, I think this is a much better way. If I know the long side, how do I find the short side? Remember what this is. The long side is equal, on a 30, 60, 90, the long side is equal to the square root of 3 times the short side. We've talked about that over and over again. So if I know the long, if I know the long side, how do I find the short side? How do I get the short side by itself? I divide by the square root of 3. So this would be 6 divided by the square root of 3. Is that my whole perimeter? No, it's not. It's just this little bit right here. That's what x is. It's just from here to here. But what if I wanted to find the whole entire perimeter, which is exactly what I want to find? So what do? I double it to get this whole side right there, and then I multiply it by 6. So I multiply it by 2, then I multiply it by 6. What's that the same thing as doing? It's the same thing as multiplying by 12, right? Times 2 to get the side, times 6 to get the perimeter. So that's what your answer is. Now you could do a bunch of things at this point. You could have simplified this, got rid of the radical in the denominator, blah, blah, blah. I think it might be just as easy to do this. So what's the perimeter? It's 6 divided by the square root of 3 times 12. Put 12 over 1. Or you could have said 72 over the square root of 3. I don't really care. Watch, it's the same thing. It's 1/2 times 6 times, let's do that, 72 divided by the square root of 3. That's what you're putting into your calculator. That's your perimeter. You already know your apothem. You put the 1/2 in there because that's your formula. And that right there should come out to 124.7 if I did it right. I'll tell you what. Nope, I'm not going to tell you what. I was going to do this on a calculator. I don't have the calculator on my computer up and ready, but I'll let you just do that yourself. Okay, I showed you how to do all this stuff. You can at least put this in your calculator. And you should come out really, really close to 124.7, if not exactly. Now, you'll have a whole bunch of decimals after this, but it rounds to 124.7, and that would be your area of this whole thing. Okay, so if I wanted to find the area of that whole thing right there, it's going to be 124.7. Alright, so we just finished that whole entire quiz, and portions of that will be on the final, so it's a good thing for you to go over it. So I think the only thing we have to do now is Chapter 8, and we'll do that in class tomorrow during 4th and 6th period. Alright, good luck as you review for this final.